Temporary push buttons. How are they programmed? Surely previously, we will have already generated code in Arduino to read the state of the buttons, to hold a specific function while the button is pressed, and release the function when it is released. But in practice, the buttons on our electronic devices work in a different way. For example, with a pressing action on a certain button they initiate a turn-on function, and with the same pressing action on the same button they execute the turn-off function. So we will learn how to program them to read keystrokes, and to choose at what moment in the interaction to execute the action. For example, execute the action of turning on the LED by pressing them. Or execute the action of turning on the LED when releasing them. Like the volume buttons on our mobile devices, we will learn to program repeatable actions while the buttons are pressed. For example, decreasing the light intensity of an LED while we hold down a button, and increasing its light intensity while we hold down a second button. Welcome. There are two traditional ways to connect push buttons to the Arduino board. The first, between the 5-volt power and ground. Connect one pin of the push button to 5 volts. Connect the other pin of the push button to the chosen pin on the Arduino board. And connect this other pin to ground through a pull-down resistor, which generally has a value between 1 and 10 kiloohms. With the button not pressed, the chosen pin on the Arduino board has a value of 0 volts, or a low logic state, and while the button is pressed, the pin will have a value of 5 volts, or a logic high state. The second way. Between the 5-volt power and ground. Connect one pin of the push button to ground or 0 volts. Connect the other pin of the push button to the chosen pin on the Arduino. And connect this other pin to 5 volts through a pull-up resistor, which generally has a value between 1 and 10 kiloohms. With the button not pressed, the chosen pin on the Arduino board has a value of 5 volts, or a logic high state. And while the button is pressed, the pin will have a value of 0 volts, or a low logic state. Taking advantage of the electrical characteristics of the 8MEGA328P microcontroller on the board, the function of the pull-up resistor, we can replace it with the internal resistance inside the microcontroller, making only the push button connected to the outside of the board, and working with the pull-up resistor of the internal chip. For our practice we will place an LED, connected between ground, and digital pin 9 of the Arduino board. On our computer, we open the Arduino development environment, the Arduino IDE. And in it, we open a new sketch. In the editor's scope, we declare the pin button variable with the pin number of the Arduino board to which we have connected the button. Then we declare the LED pin variable, with the pin number where the LED is connected. Inside the void setup method, a method that is executed only once when the Arduino starts. With the pin mode method, we configure the push button pin as a digital input with a pull-up resistor. Then we declare the LED pin as a digital output. Inside the void loop method, a method that is executed cyclically or repetitively, we place two if-type control structures to evaluate the two possible states of the button. In the condition of the first structure, that is, the part inside the parentheses, we evaluate whether the digital reading of the push button pin is at logical low or 0 physical volts. And in the condition of the second structure, we evaluate whether the digital reading of the push button pin is at logical high, or 5 physical volts. In the action of the first structure, that is, the part between braces, we place the value of the digital pin of the LED in a logical high state, or 5 physical volts. And in the action of the second structure, we set the digital pin value of the LED to a logical low state, or 0 physical volts. We upload this code to the Uno board. And here we see the function of reading the state of a button associated with a state of the LED. Switched on. Switched off. Now we are going to learn how to read a keystroke, not states, but keystrokes, that is. Upon a complete press, that is, pressing and releasing the button, the LED turns on, and upon a new complete press the LED turns off, and so on. For this, we are going to start from the code that we have already developed. Let's delete the writing of the LED states. And within the condition of the first if structure, and with the character ampersand, we place a conjunction, equivalent to an and logic, with a decision variable that we will evaluate if it is in the true state, that is, so that the action of this structure if, both conditions must be met in the conjunction. And in the condition of the second if structure, we will perform the conjunction evaluating whether the decision variable is false. Then, in the action of the first if structure, we change the state of the decider variable to false. And in the action of the second if structure, we change the state of this decision variable to true. The code we just made is a one-click weak edge detection structure, a structure for detecting the falling edge, and a structure for detecting the rising edge. Here we observe the graphic behavior over time of the voltage of the Arduino pin associated with the button, and how it responds when pressing the button, or when releasing it. Graph where we can see that, for a first complete press, that is, pressing and releasing the button, we have a falling edge, from 5 to 0 volts, and a rising edge, from 0 to 5 volts. And for the next complete presses, we will also have the falling edge, and the rising edge. Therefore, once the edges of the voltage wave have been detected with these structures on the screen, it is simply choosing which edge to execute the action of turning on or off the LED. So suppose that we will activate the action on the falling edge, then inside the first structure, we place the instruction to write the LED pin, with the inversion or negation of the current logical state. This will change the current state that the LED has, i.e. if it is off, it will turn it on, and if it is on, it will turn it off. I will save this code with the name push button 2, and upload it to the compatible Arduino Uno board. And here we can see the behavior. One press will turn it on, and that same press will turn it off, and so on. Now, let's understand what we did here. Here we have the voltage variation of the pulsation over time, that is, pressing and releasing the button. We have the decision variable, with its variation alternating over time between true and false. And we have, of course, the timeline. Let's start moving this timeline through the push, to this point here, before pressing the push button, where we can see that the voltage has a logic state high, and that the decision variable is true. So, if we see in the code, the condition of neither of the two structures is met, so no action is executed at this moment. If we advance the timeline to this point here, at the instant where the button is pressed, we see that the voltage has a low logic state, and that the deciding variable is true, so in the code we see that the condition of the first if structure is met, executing the action of changing the state of the decider, and turning on the LED. If we continue in time up to this point, that is, while the button is held down, we see that the voltage continues with a low logic state, and the decision variable now has a false state, so we see in the code that does not comply with the condition of neither structure, so at this time no action is executed. If we continue in time, up to this point here, where the finger is released from the button, we see that the voltage has a high logic state, and the decision variable has a value of false, fulfilling in the code the condition of the second if structure, and then triggering the change of the state of the decision variable to true, then detecting the rising edge, to prepare for a next pulse. Later in time, with the voltage in a high state, and the decider in a true state, the conditions of the if structures are not met, without executing actions at this time. Now, note that the action of turning the LED on or off occurs on the falling edge of the voltage, that is, at the precise moment we press the button. If I want to execute the action on the rising edge, then I will cut the LED state change action, and paste it into the second if structure, and upload the code to the board again. We can then see the function of the button in a similar way, but, this time, the action of turning on the LED is executed when the button is released, as is the action to turn it off. Now, if up to now you are wondering, but if I have more than one button, how do I code the program of these other buttons? Well, if you have a second button located for example on pin number 12 of the Arduino board, and a new LED that you are going to associate with this second button, located on pin 10 of the board. I'm simply going to copy the two if structures, for edge detection, and paste them immediately below, and in these two new structures, I will update where appropriate, the variables for a second pin for the new push button, a new decider variable, and a new variable for the pin of the second LED associated with this second button. And that's it. At the beginning of the code editor, I will update the global declaration of the new variables, for the second button, for the second LED, and the second decider for the edge detection. We upload this program to the Uno board, and that's it. Here is the result. Now, we continue with the repeatable functions as long as we hold a button pressed. In this case, with a first button to increase the light intensity of an LED every 30 milliseconds, and with a second button to decrease the light intensity of the same LED. So, from where we left the previous code, I will delete everything inside the void loop. And with the analog write function, we will assign to the LED pin a variable that I will call brightness, and that can take values between 0 and 255. Of course, at the beginning of the code, I will declare it globally as an unsigned integer, and initialize it with a value of 0. Inside the void loop method, and before executing the analog write method, I will place two if control structures, and in the condition of the first, we will evaluate whether the state of the first button pin is low. And in the condition of the second structure, we will evaluate if the state of the second button pin is low. In the action of the first if structure, I will place another if structure, just like in the second initial structure. In the first inner if structure, we will evaluate whether the brightness variable is less than 255. And in the second inner if structure, we will evaluate whether the brightness variable is greater than 0. These if will serve as numerical limiters between 0 and 255. If the first internal condition is met, we will increase the brightness variable by 1 unit. If the second internal condition is met, we will decrease the brightness variable by 1 unit. Then we will place a delay of 20 milliseconds, which will indicate the time in which each brightness modification is repeated, if we have a button pressed. And here is the result. Dear friends, I hope you enjoyed the video. A special greeting from Electronic Spot. See you in the next one.